Gentlemen, welcome to the first training class for Cecil and Sons Heating and Cooling. Every Saturday we are giving out free training, and right now what you're looking at is just a board of some basic controls and some high voltage. So what we have here is just a regular on and off switch, light switch. I'm sure you see one in your house. This is actually fed by 120 volts in this particular application, with 115 volts. So we have a switch here. This will be a step down transformer. It goes from 120 volts down to 24 volts, which actually controls a lot of your basic controls in your heating and your air conditioning system. This right here would be a thermostat, which will only be for one heat, one cool application. This other thermostat will be for a heat pump application, and that is your outdoor unit doing air conditioning and heating. This right here will be a defrost control board that you would find inside of a heat pump system, along with a contactor. What it does is just passes voltage from one side to the next after 24 volts is applied to it. But we are going to get into all of that. This here is also a contactor. It is just a double pole contactor, but similar to this one, it is worked off of 24 volts, and it too also passes voltage from one side to the next once 24 volts is applied to the coils. This is a induced draft fan motor, which is actually found inside of a gas furnace, but for testing purposes, it was small. We put it on a board. It works just like any other blower motor. So we hooked it up to simulate a fan motor inside of a air handler situation, or inside of a gas furnace situation once a coil is applied. This underneath of that is also a control board that you will find inside of a gas furnace. And what happens here is that this gets 24 volts, and then the control board kind of has a mind of its own, and it'll run through some cycles and then in turn turn on this fan. So the purpose of this particular video is just to teach you guys how to utilize a voltmeter, which is this right here. This is your voltmeter. So you would utilize that to check power across your board to verify any defects in troubleshooting. We check voltage in AC volts, which is alternating current, and I won't get into that. And the other voltage check is DC voltage, what I won't get into that. But for today's lesson, and what we're doing is you want to check voltage in AC volts. That is, all your household voltage will be AC volts, which is alternating current. All right, so the first thing that I am going to do is I'm going to flip the switch on. So right now I have off on both of my stats. I want to make sure that they are all off. Emergency heat off. Okay. So this one, the heat pump thermostat, looks like it has batteries in it. That's why it's on, but it doesn't have or it has 24 battery power. I'm sorry, it looked like it has battery power because I know it's no power on it because we haven't flipped on the switch yet. This other stat that you see out is probably operating on 24 volts, which is why it is out. But in any event, let's flip on the switch and see what we got going on. So first off, my stat is not lit, so I can already assume that we are probably having some voltage issues. So what I'm gonna do is I'm gonna just check voltage. This voltage right here, I know for a fact once the switch is on, this voltage comes directly, so it should be hot once the switch is on, and it should read 115 volts. So already we got some troubleshooting situation going on. Give me 1 second and let me check the power source into which we are in. Okay, and some help from my lovely assistant there. Y'all can't see the lovely assistant, but she's definitely in the building. All right, so now it looks like we got some voltage. So now this should be reading 120 volts, and it looked like one of the stats was already on because there's a contact in. But if you can see that, that's 120 volts. That is on alternating current, and we pretty much now just ran through a complete cycle on the heat pumps side. Let's see if I can shut that off. All right. So that looked like it just went off. So what I'm gonna do is give me 1 second. I am trying to locate some tools. Now that is off, so I'm waiting for the fan to shut off because we are now off in every single position. So typically what happens when you go inside somebody's house, the first thing that you want to take a look at is the thermostat. You'll go to the thermostat and you'll turn it on to heat or cool. For this particular demonstration, we're going to be doing it in cooling. So just to run through the steps of the sequence of operation and how the unit actually works. So normally what you'll see is a switch or some type of power source, and that power source will lead back to some type of circuit breaker where the power actually originates at. So one, you want to make sure that you got power. Two, you go to your thermostat, and I'm gonna pop this off. And just today we're just gonna be totally checking voltages so that we can see what it's supposed to be doing, what, when, why, and where, and what voltage it should actually have on it, and how to check voltage to see if you actually have a call on your system. All right. So I don't know if y'all can see that or not, but this is the typical wiring setup for a heat pump application and then the straight AC application. And what you will find underneath of them both is a common wire. You will find a red wire for 24 volts. You will find a blue or a O, which represents the reversing valve. You will find a yellow, which represents cooling. You will find a green, which represents your fan. And then you will also find a white, which represents heating or emergency heat in this situation, if we're speaking of a heat pump. And just in a regular straight AC system, you'll find some of the same similar wires. You'll have a green for the fan. You'll have a yellow for the air conditioning side. Your white wire would typically be used for heating, and then your red is where your voltage actually is. So what your thermostat is actually doing, so when you go to your thermostat and you check from common to red or common to your 24 volt side, you should have 24 volts. So I'm gonna go from C to R, and I don't know if y'all can see that, but that's reading 28 volts, right? So what happens is that common is like a ground. It remains the same. So if you check common to any other wire, you wouldn't get nothing. But if you check red to any other wire, you would get 24 volts. Okay? So what your thermostat ultimately does is that it jumps power from one side to another. So you say, okay, thermostat, I need air conditioning. Right now it's 79 degrees where I'm currently standing. So I'll take and turn that to cool, and I'll put it below the 77 degree set point that's actually inside the room right now. And then what will ultimately end up happening is, and this will probably take some time, because the thermostat has most thermostats have what's called a time delay. It have a time delay on it, so it'll take maybe 4 or 5 minutes for the unit to actually register. So time delay up, and the chattering that you're hearing is, and this is a normal. typical troubleshooting problem that you'll run into. So this contactor is apparently going bad and probably has some junk or some dust or some dirt or something in it. But in any event, now that we have power, we'll check from, and your first call on the system in air conditioning. So the first call would be to yellow. So now from common to yellow, you should have 24 volts, right? 24 volts. Because your thermostat just registered that you want cooling, so it in turn shifted power from the red wire to the yellow wire in order to give you 24 volts to this coil. So now your coil will activate and it will transfer power, your 120 volts, from one side to the next, i.e. turning your lights on. So now what we're going to do is I'm going to shut it all off again. So the fan on the control board, once it actually powers down for efficiency, it'll run for a few seconds before it actually shuts off. But this is all being operated through this control board. So once the control board recognizes that there's no more 24 volts applied to the system anymore, it'll go ahead and begin the shutdown process. Boom. So we're off. So basically this video is strictly for just showing you some of the simple troubleshooting techniques or how to utilize your voltmeter in terms of checking power. So you will have 120 volts here still, but now that the system is shut down, you will have no 120 volts here because you haven't activated anything yet. You haven't asked the system to do anything. So there's no 24 volts that's being applied to this contact coil in order to close it. Now, sometimes for testing purposes, what I'll do is just to see if my unit works, and this is simulating like an air conditioning unit. So I'll go to it and I'll do this. So now I know that the unit actually works and that it does have power just because it's coming on. All right. So let's run through it real quick one more time so that we all on the same page. This right here is my switch where my high voltage lays at. This is my transformer. It's actually referred to as a step down transformer. Super important. And these are all steps. And whenever you're troubleshooting and your unit is not working, these are all the steps that you actually want to follow. You want to make sure that you have power. Once you know that you have power and you verify power, you want to make sure that you have 24 volts, because without 24 volts, you cannot run nothing on the system. Everything is controlled by 24 volts. Once you verify that your transformer has voltage and it has 24 volts coming out of it, then you move on to your thermostat. You see if your thermostat has 24 volts on it. If your thermostat has 24 volts on it, then you move down to your control board situation, either at your air handler or your outdoor unit. You make sure that you have 24 volts. Make sure that you have 24 volts there. Then, once you have verified all of that, you know you got power. So there may be some other things that may be wrong with your system. This particular control board, the defrost control board, just for testing purposes, these are actually low pressure switches that we have jumped out to simulate that the unit actually has good pressure. So it's a low pressure switch, high pressure switch that we got jumped out, and those are some of the things that you'll run into with systems that'll be low on freon. So you'll be trying to figure out why it's no power or why your contactor is not pulling in after you have asked it to actually come on. It's because now you have ran into some type of fault elsewhere, but you don't pass any steps. The meter is your friend. This is you want to make sure that you know how to use this meter and you know how to troubleshoot and check power. Okay? Remember that we are working on AC volts. AC volts is what you want your meter to be on. AC volts. If you can see that right there. Volts AC. That's what you want, because that's what we're working on, which is alternating current. When you're checking power, you just want to run your leads across your power side, 120 volts. You can also check ground. For this particular situation, we didn't run a ground, but you could also check from a ground terminal to, and only one wire, particularly on a 115 volt system, would be a hot wire. One of them we consider a neutral or a common. But 120 volts. Definitely want to learn how to utilize the meter to check voltage. Super, super, super duper important. Never, ever, ever, ever pass no steps. Always want to make sure that you're running through the steps. So one more time, we're going to turn all this on. So what I want you to focus on more than anything else is that. So right now, from common to yellow, we have 0 volts. No voltage here. From common to red, we have 24 volts. From red to yellow, we have 24 volts. So your thermostat, ultimately what it's doing, once it gets a call, it is going to take power from the red, shift it over to the yellow. The common wire remains. It stays. It's just a ground wire. So we're going to turn this back on again. We're going to watch it run through the cycle. Remember that the thermostat has a delay on it, so give it some time to show up. So now that our system is actually running, or our light is on, if we check from common to yellow, we got 24 volts. This is what actually just pulled in our contactor. So we have no faults nowhere. Common to yellow is how you check to see if your unit has a call on it. So once you walked over to your thermostat, you flipped it on. If nothing happens and you got power from common to yellow at your thermostat, then you probably have a fault somewhere else. But the meter will help you to determine and dictate that. But you need to know how to use it. Volts, AC, 24 volts. Common to yellow, 24 volts. If we take it, shut it down, put it in the off position, if we go from common to yellow again, 0 volts. No voltage. And I don't know if y'all can see that or not, but 0 voltage. So now if I take off the common and go to the red, I know that I have an active 24 volts still. So that also lets me know that my transformer is still good because I have 24 volts. If I didn't have 24 volts, then I would go backwards to this. So that concludes today's video. Just to recap, I just want to say that this right here is a basic trainer of a basic heat pump system and a basic air conditioning unit. We have 115 volt power wire coming in. We have a step down transformer from 115 volts down to 24 volts. We have a one heat, one cool stat. We have a heat pump stat. We have a defrost control board and 2 contactors, and also a fan, and also a fan, which is we're simulating as a blower motor, but it is actually a draft motor. For all you smart guys out there, it's like, man, that's not no blower motor. That's just a draft motor. But for testing purposes, we're using this for to simulate a blower motor. It was actually a draft motor out of a gas furnace. This right here, we actually also took out of a gas furnace. It is a control board, and we also had that wired into the one heat, one cool system. So at the end of the day, volts AC. This is your meter. Simple meter, nothing serious. This one right here is a field piece. I probably maybe spent $70 on it, but it's good for residential checking AC voltage. Also has a pretty cool amp clamp on it. Probably get into that a little bit later, but you clamp that on there. Once you get whatever it is, the load that you're trying to run, you can determine how many amps is actually drawing down by using this amp clamp. Also want to go over some stuff, just some simple stuff with the meter, because the meter is super important. So not only that on the meter, what you also can do is which is imperative in the troubleshooting side. So continuity checks. Continuity checks are super important, and what a continuity check does is, it allows you to verify whether or not if your wire has any break in it. So you think when you inside like a residential home, the thermostat may be upstairs and the actual unit is probably downstairs. So in order to figure out whether or not if you have a bad wire, you use what's called continuity, which is just basically a complete circle. And we'll get into that maybe on the next video on how to check continuity. But right now, just go over some things with your meter. Make this meter your friend. Go around your house, turn it on AC volts, stick it inside the plug, see if you got 120 volts. If you don't have one of these, definitely go invest in one of these. This right here, just like I said, a typical voltmeter. Cost me about maybe 70, 100 bucks. I'm not sure, but I definitely wouldn't go out and spend a whole bunch of money, on a meter. Not at this stage in the game for for any beginners. But you definitely are going to need a meter. A meter is your friend. This is it. This is what sets you aside. This is what you need to know, learn, and be able to utilize this meter right here, because this allows you to figure out and troubleshoot electrical issues in electrical circuitry. All right, that's it. I'm Stacy. This Cecil and Son. We are out for now. Please like, subscribe, all of that good stuff to Lee TV YouTube channel. Peace.
No, you gonna have your